Hey guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I kind of like to request our members to subscribe and also engage us in the comment section and ring that notification bell to be getting updates on our various discussion in mathematics and sciences. Now in this particular discussion, I'm going to look at some of the properties of the alkaline earth metals. And of course, this is going to be some of the properties, of course, of various compounds which are going to be formed in combination with this specific element. Now, this is going to be a wide range of compounds, ranging from hydroxides, carbonates, fluorides, oxides, and even, of course, sulfates and other compounds which we are going to mention for group 2 elements. Now, in some cases, we're going to do a comparison between the alkaline earth metals and alkali earth metals, and that is going to give us a contrast between the two. And therefore, for this specific discussion, we're going to look at some of the properties. And in this case, I mentioned the concept of hydroxides. So we're going to see that the hydroxides of the group 2 elements are going to be contrasted from the group 1 elements, in that for group 1 elements, the hydroxide of group 1 elements are going to be requiring less lattice energy, compared to group 2A elements. So in this specific case, we're going to look at this specific case of lattice energy. I mentioned this specific concept on the concept of enthalpy and enthalpy change under the topic of thermochemistry. So I'm going to put a link of this specific discussion so that in case you need to inquire more about this particular concept, then therefore it's going to be clearer for us. So in this specific respect as well, we're going to look at other products which are going to be formed by the group 2 compounds, which include the carbonates, the fluorides, of course, these are going to be the halides, and then we're going to have the oxides of these group 2 elements. They are going to be, of course, displaying some kind of solubility, whereby we're going to describe this one to be slightly soluble. And if we talk about this specific general characteristic, of course, we're going to assume basically that this is going to be solubility in water. So in this case, the carbonates, fluorides, and oxides of these group 2 elements are going to be described as slightly soluble. Now, for the hydrates, these group 2 elements are going to form hydrates. And in this specific respect, we can have a general description for this specific formation of hydrates using this formula, whereby we're going to have this one given as such, these 6 molecules of water given as such. So in this case, M is generally going to represent the various range of group 2 elements for the metals of magnesium, calcium, and then we're going to have strontium given as such. So this specific representation is going to be for halides, and in this case we can give an example for chlorine and bromine, which is specifically are going to be forming this specific part of this particular hydrates that I've given on the board. So these are some of the properties which we are going to witness for hydroxides, carbonates, fluorides, oxides, and hydrates, which are going to be displayed by group 2 elements. Now, in this specific case, I mentioned the concept of solubility, and whereby I mentioned the concept of carbonates. Therefore, we are also going to see that for the sulfates of these group 2 elements, they are also going to be displaying some kind of a characteristic, but in a sense, they are going to be, of course, insoluble in contrast to the one that we have given for slight solubility given as such. So in this case, then therefore we can have, perhaps I can just do away with this. So we're going to have the sulfates of these group 2 elements, which are going to be insoluble in water. And this one we can give various examples of this, of course, sulfates, which are going to be calcium sulfate, strontium sulfate, and barium sulfate. They are going to be displaying this specific aspect of being insoluble. So in this case, in some of the tests for specific ions, metal ions, we're going to see that it is one of the properties which is going to be exploited, whereby they're going to form some form of precipitates, and therefore that's going to be one of the confirmatory tests for trying to find out some of the presence of metal ions in solution forms. So in this case, this is going to be one of the properties. So if you try to look at the oxides which I've mentioned together with the fluorides and of course these specific carbonates, the oxides of these specific metals, as we said, they are going to be formed whereby metals are going to combine with oxygen. And we can just give a general formula for formation of these specific oxides using this general representation as such. So in this case, I'm just going to assume this aspect of stoichiometry and give a general representation for the formation of course, oxides of these group 2 elements by using that specific summary. Now we can have also the representation for formation of halides of these group 2 elements, whereby they are going to combine with this, of course, molecular, of course, 2 atoms of this molecule of a halide, and that's going to lead to the formation of metal halides given as such for the group 2 elements. So this list is going to go on. Of course, we can give us a representation for formation of sulphides, which are going to be given in terms of, for example, I can give this one for magnesium. So we're going to have magnesium sulfide being given as such. And in case if the metal is calcium, then therefore that's going to form a product of calcium sulfide given as such. So we can as well give this one for the formation of nitrates, and that's going to be given in this specific form. So therefore we're going to have this one given as such. So it's going to be 3,2, and then we shall have this one 3 given as such, and that's going to form. So these specific reactions are going to be displayed using those wide range of formation for oxides, perhaps halides and the sulfides, nitrates, and then we shall have also the reaction. So there's one of the characteristics that we had mentioned, of course, which is going to be displayed by barium, which is going to be an amphoteric property. Of course, we had given 2 equations in that particular discussion, which was showing the formation of complex ion for positive and negative. And I can give one of the examples which we had described, perhaps in trying to give this special property of barium, which we are given as the reaction between the hydroxide ions, and that's going to lead to the formation of this complex ion, which of course will be given in terms of that particular representation. So this is going to be accompanied by a formation of hydrogen gas, and that is going to be one of the examples of the unique properties of barium which we had mentioned. Now, to mention but a few, those are going to be some of the properties which we are going to witness being displayed by group 2 elements. And as we go by, we're going to mention others, of course, in various reactions, especially in application of some of its compounds, especially in terms of reactions, and of course in other, of course, equation sets and other areas that we're going to come across. So that is it for now, guys. Kindly check our description boxes for various links of other similar videos which we have already done or we're going to do in our description box. So that is it for now, guys. Bye. God bless you. Catch us in our next video.